Hey everybody, I turned on the camera here because I found something really sweet inside this Sony CD player clock radio thing. It's Network Audio System NAS CZ1 model, and I'm trying to fix the CD player because apparently the CD player laser diode wasn't coming on, so I figured I would crack it open just to see if I could find a loose connection inside there on one of the ribbon cables on the CD player assembly might have come loose. But the thing I want to show here is this. Look at that. That's the main power transformer, and it's got, I mean, just look at it. It's the core is all curved like that. It's got the different widths on all the laminations in there, and the coils are all on round spools. That is the sexiest transformer I have ever seen. Let me see if I can take off this top cover to get a better view. And there she is in all her glory. We got the high voltage side coming in here, low voltage coming out there. And let's just take a look at the windings. Looks like low voltage comes off of both coils in here, both bobbins. And high voltage probably goes to both bobbins too. I would imagine that's the high voltage line right down in there. It will be wound one coil here on the inside and another coil on the inside of this one too, and that makes sense for worldwide distribution of these things. So this one is wired for 120, but if you want to put it in a 240 installation, then you just put both of those coils in series rather than parallel. But yeah, I mean, look at that. I'm going to have to look up the manufacturer, Kitamura Kiden, to see more about this. I think what they do, just by looking at it, you can see there's a spot weld right there. And I guess they wind the core first. They have a big long strip of this thing, and it's already precision cut along the whole length of this single strip of iron, and they wind it on a form and put all the gunk on it to hold it all together, and then they put on these bobbins, and you can see each one is cut. There's a cut right there, and somewhere inside there will be another cut. So these are put on in two halves and then glued together, or maybe sonic sealed together. Probably they want to do it real fast, so they would use some kind of industrial process to seal the two halves together very quickly. And then you can see the teeth on the end of the bobbin here, so that would go into a machine to spin the bobbin real quickly, while there would be a coil of copper wire, a spool of copper wire would be deposited onto the bobbin as it spins. Man, don't you just hate it when that happens? I got the thermal grease all over my fingers from that thing. Anyway, here it is. It's I'm at the Kitamura Kiden website, and I guess they call it the R-core transformer. And I was reading here, they say that it's the flux, the leakage flux coming off of this R-core is 1/10 of that of a typical EI-shaped transformer. And apparently this R-core transformer has half of the iron loss too. The magnetic resistance is a lot less because there's no gap like you would have with an EI transformer. And the metal that they use is called Shinitetsu. It's a Japanese company, so that's why they got all these funky names like Shininetsu and Kitamura Kiden. Anyway, I was looking at applications too, and you can see they audio equipment application number 1, and then here's more power amplifier, preamp, CD player, subwoofer. All this audio visual equipment is their main application for this kind of transformer, because of course you wouldn't want to have any kind of 60 hertz noise coming off of this thing from any stray magnetic field. I mean, the other option is, of course, to use one of these things. I think I took this out of some audio stereo player or something like that many years ago. It's got a big fat iron or a copper ribbon all the way around both coils. That just helps to reduce any kind of magnetic leakage coming off of the core. But this one has much less magnetic leakage than even that, and that just prevents any magnetic leakage from getting into anything else in here and causing 60 hertz hum in the audio. And of course you wouldn't want to replace this with a switching power supply either, because then you're going to have other inaudible yet high frequencies that might also cause problems with the operation of the device. And then there's this transformer over here. This was mounted on the assembly that I took down. It was mounted like that, and it's a really small transformer hooked up straight to the mains, it looks like. I think this is just for standby power, just a little dinky thing, so not really much to worry about this one. But for the high power, for the good audio quality, that's what this one is used for. But man, this thing is sexy. Even the name Kitamura sounds like a sexy name for this thing. If you want to design a product that looks good on the inside as well as the outside, this would be the thing to use. See you later.